Hey, it's Mr. Mabry, and it's time for part 2 of our notes on different methods for reproduction. You should have already watched the first part on asexual reproduction, and in these notes we're going to go over broad strokes, the differences between sexual reproduction and asexual. Now let's quickly review this umbrella that you created on your first set of notes. Over here we learned last time about how asexual reproduction is having one parent, and the one parent just copies their DNA through either binary fission or budding, or through regenerating or breaking off a fragment of themselves. Well, this is to contrast with what we're going to talk about now, which is sexual reproduction. So sexual reproduction involves at least one other partner. Now, depending on some different plant and animal species, there might actually be multiple partners involved, but it's most common just to have two partners. And because there'll be some sort of a little spermy guy swimming along who finds some sort of egg, and in case you didn't know, it's true that other organisms, and even plants to some degree, have sperms and eggs to join together to combine to make an organism with multiple sets of chromosomes, like we've learned about with humans. And as you know, humans, we have 23 chromosomes from dad's sperm and 23 chromosomes from mom to give us two sets of chromosomes. Well, other organisms have these two sets of chromosomes as well, even though they differ in number than we do. Now, the methods are slightly different, but you're going to see overall they're sort of the same. Sometimes you can make a baby internally, sometimes you can do it externally, and sometimes when you make a baby internally, you end up laying an egg or giving live birth. So let's delve into the weeds a little bit. All right. So here we're just reiterating again. We have an egg and sperm, we're making new organisms, and they are different from the parent. You don't need to write this slide down. It's just a reiteration of what we just talked about. But now let's talk about internal fertilization. Whoa, come back. Okay, so let's write down internal fertilization. Fertilization occurring within the female, hence the name internal. The organisms that this most often occurs in are mammals, insects, birds, and reptiles. Now, mammals, often give live birth, which is how you came into being. Same with these lions down here. Most things that you think of as furry and cuddly, and even those mammals in the sea like dolphins or manatees, they give live birth. However, other organisms where they're fertilized internally, insects and birds and reptiles, they end up laying eggs. However, in all circumstances, the sperm and egg came together inside the organisms before the baby came to be. And you might be asking yourself, well, why is that? Why make a baby on the inside? Well, the main benefit is that the parents tend to be more protective. Let's write that down. Protective of the young during development. Whether it's they lay an egg and then they're guarding that egg that they laid, or it's like, say, for a human, for 9 months, that baby is safe in the belly, and it's really hard for something to happen to that new sprouting person because the mom is protecting it. And so this increased chance of survival really makes internal fertilization the way to go for these animals down here. Now, there's a lot of cool ways on how these organisms end up combining the sperm and the egg together, but I don't want to go into those details because the project you're doing after these notes, I'm going to assign you a random organism, and you get to look up the specific way that they mate and are able to fertilize that egg. And so I'm going to leave that excitement to you for that next project. But let's talk now about external fertilization. As you can guess, external means it occurs outside the female. And this usually means if it's occurring outside, you need water. That's the most common medium used to connect the sperm to swim towards that egg. And this usually totally grosses people out. Here's a picture of two frogs hanging out, doing their business. And there's a female who just dropped those eggs, and this guy is on top, and he's going to squirt some sperm out to go and attack those eggs. And fish and amphibian, those are the main organisms that are doing this external fertilization. It always super grosses you out because you see it's just going on right there in the water. And then once you do it, they're gone. Those parents are gone. They're like, see you later. I got things to do. They don't hang around. They don't protect the eggs. You hope nothing comes along to eat them. And so you can see a big drawback of this external fertilization is you're just not sure if they're going to survive. Things that come along and they can eat you, or maybe things get super hot. They could cook the eggs, or maybe the pond dries up. And for that reason, I mean, those frogs and those salmon and those different fishes, they just squirt thousands of eggs and sperm, hoping a few are going to survive and develop into the young. And so to summarize, and that's it, folks. That's it for sexual reproduction. Is those methods: internal and external fertilization, either giving live birth or giving birth via eggs. And you can see here, these are the most common descriptors of why organisms would choose one method over the other. I mean, asexual, what it's got going for it, it is fast. I mean, those bacteria can boom, 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 just pop out kids, which could be really powerful if you need to overtake something. And in fact, when you get sick, it's because you have bacteria inside you with like strep throat or an ear infection, just reproducing like mad. And one of the cons with sexual, oh nuts. Well, sorry guys, I had to go back and fix my slide because, as you can see, I had these in the wrong box. So if you went ahead and copied, I'm sorry, go back and fix it. Asexual reproduction, fast reproductive rate here, and that's the con of sexual. It's slow to reproduce because it takes time to make something as complex as a mammal or as an amphibian or as a fish. And so, it takes a long time to reproduce humans, where, this takes 9 months, where this, it takes like 10 minutes, and you're like, boom, bacteria. But unfortunately, the reason it's so fast is because they're just doing the same thing, the same DNA. But over here, for sexual reproduction, it's like, no way, every time you make a new plant, you make a new fish or amphibian, there are different qualities coming together, different traits and different alleles, which is really powerful. It's why humans have been around so long, because we've been able to adapt against diseases and to different environmental conditions, and we're really flexible. It's hard to kill species that have sexual reproduction because they're always able to recombine their genes in creative and new ways. Now, the next thing we're going to do is we're going to learn specifically how plants make use of sexual reproduction on a slightly different PowerPoint, and then it is game time for the baby project, where you have to sell me and the rest of the class on why your organism reproduces the most cool way. So get pumped. Woo!